think I'll switch off the Q&A now.
Okay.
Yeah, and then just for the audience, the Q&A will be switched on again after the presentation. Yeah, so that we can have back and forth communication.
Yeah.
Okay, so the Q&A is now closed. Now it's closed.
Okay.
Okay, I will mute myself now, and I think you can go ahead, Chipusur.
So I'm live now. Yeah. Okay,
Yeah,
so
yeah.
Alex, you can start recording. So welcome everyone to the presentation. So the idea behind this presentation is that we have this framework that we've been used to developing DApps and white papers for blockchain related projects. So we turn this into a proper academic framework and try to make some research based on this and develop a framework. So we want to present to you this framework and some interesting use cases that we have done with this framework, and then get your feedback regarding this framework. Okay, so we are the Blockchain Technology Group in Tautech, and welcome. Okay. So first, we did a research, I think sometime in 2017, where we tried to find some blockchain use cases in organizations. So because I think the idea about the apps and this organization aspect is quite different, because in the organizations we are talking about real enterprise users. Is not just for finance, for Bitcoin, for transfer, but real enterprise uses in solving organizational or inter-organizational collaboration problem. So one of our findings, one of the findings we made is that one of the topical issue is the transparency and trust. So when organizations collaborate or when they work together, one of the things they want to solve is this transparency issue in terms of access to data, or who owns the data, what can you with this, what have you done with this data, and what can you do. So the next one is this security issue. People want to have control about their data they share, especially in inter-organizational processes. So this, when you collaborate with another organization, when you share data with this other organization, you also want to retain control of the data, and you also want to ensure that the privacy of this kind of data is always in place. So another point is also resource management. Organizations want to track how they manage the resources within the organizations and also inter-organizationally. And tamper-proof, you want to see the visibility of this asset or information that is shared. If there's changes to it, you want to be sure that these changes, everybody have the same record of information. Because in centralized systems, you can't know when there is a tamper-proof, because you don't have access to the database. Another company already have access. And then lastly, we talk about interoperability of information system. So all these old technology EDI for executing inter-organizational processes, they are not interoperable with our organization. So it's either one organization runs it and there's no way where everybody runs it and have the same information. So with blockchain, organizations want to ensure that they are able to share information with each other seamlessly when collaborating to execute a particular process. So then that is the background of the research we did, and we actually found out that blockchain have very good use cases for inter-organizational collaboration. So, but there is a gap. There is a gap in terms of why organizations haven't adopted blockchain and why they are not using it, or why there are not many apps for inter-organizational collaboration. So we found that there's an absence of a proper software development approach for building the apps. So we did a research and we found out existing methods. If you look on the left here, you see some of the common methods. The first three, 1, 2, 3, 4. So the first 4 are based on research, like people that propose some ideas on how to build the apps. And the last 4 is what we gathered after we talked to developers and designers in this area. So we found that some of these tools, for instance, is ontology driven. They are specifically focused to solve one problem at a time. So we don't have this general solution that helps to address something like usability, security, and these kind of things. And then when we also interview with these developers, we saw that they all use agile UML diagrams, BPMN, but still their focus is quite different. For instance, in standard UML, it's mostly for technical documentation, and for BPMN is for stakeholders communication. And freehand sketch, a lot of people like freehand sketch, but it's not standardized, but because it gives them a lot of flexibility. So then we proposed a way to solve this problem that if we do a model-driven approach for building DApps, this could also help us to solve some of the problems that we face. So we pick important problems that we can solve with these model-driven apps. So first of the problem is usability. So the usability in terms of people understanding the blockchain technology, the basic concepts of blockchain technology in a pictorial way, like in real objects that human can understand. So another thing that we also want to solve is this cost scalability, because if you have these on-chain transactions, if you build your DApp and everything is on-chain, so you have a problem where the cost may be too much. So we also want to solve this problem by using model-driven approach. And then lastly, we also want to provide design and development support for developers using our user stories and these kind of things. So here is the main concepts for the DAOM, that is decentralized agent-oriented modeling. On the left is the Go model, and at the middle is the component architecture, and then the last is the sequence and the use case demonstration. So if we look at it individually, so we use the first diagram to model the requirements of the apps. So the requirements contain what you want to execute in the app, the functions that you want to capture in the app. You also want to know who is performing what function and how is this function executed. So the goal captures the main function, the functions and the sub-functions. The quality goal captures the software aspect of how you want to implement the goal. And then the emotional goal captures the feelings of the users when they want to execute this particular blockchain function. And then we also have the user story, which helps us to easily map our agent-oriented modeling approach to Kanban or other Scrum methodologies for building DApps, for building traditional softwares, I mean. So in the middle, we have the static architecture. The static architecture is mostly made up of the components and the subcomponents, and we also have the interfaces and the tokenized components. So here in the first part, we capture what is executed on-chain. We call it on-chain function. And when we map it to the component architecture, we refer to it as a tokenized component. So in this case, this component, there is exchange of value or exchange of assets. So if the asset you have in your DApp is tokens, then whenever you execute a function, whenever you access this interface or interact with this interface, there is either a gain or a loss of this particular asset. Then the last one is where we demonstrate the use cases for the DApp. So here we demonstrate what is the transactions that are contained in a particular operation. So if we have a given DApp, we want to capture the main operations that we want to execute in this DApp. And then any activity that results in the change in state of the blockchain, this we refer as the on-chain transaction. We present this in detail when we describe the running case, but this is the general information for the requirement diagram, static architecture, and then the behavior diagram. So to capture the whole idea about the DAOM, because we have 3 different diagrams, we have many elements and how they relate with each other. We have this something we call the meta model. So the diagram you see on the left is the meta model of DAOM. It shows all the elements that we have in the DAOM framework, and it also shows the relationship between these elements. Yes, so if we look at them one after the other, so the first element is the goal. this is the goal. So the goal I said before is the function that we want to execute in the DApp, and this goal can be refined into, you refine this goal into first level goal, second level goal, third level goal, and nth level goal. So the detail of the refinement shows how the detail of the requirement of the DApp you want to build. So the more you refine it, the more you have a concrete picture of how this DApp is going to work like. And then we, in the first level refinement, that is the first level goal, this we map into the main components of the DApp. And then the second level represents the subcomponents. Okay, and the other elements we have associated with the goal, we have this quality goal, we have emotional goal, we have the user story, we have the agents. So like I said before, agents are people or users or software that executes a particular function. So when we have a agent, it could be a autonomous agent, it could be a non-autonomous agent. Autonomous agent means that you want this particular function to be executed automatically, autonomously, without interference of anybody. So this is executed by a computer or a software. Then we have the user story, which describes the on-chain functions. So the user story captures the story behind how the user tells a story, how the on-chain functions affect a particular user. Then the emotional goal captures how the user wants to feel when they interact with a particular goal. And then the quality goal describes the software aspect of how this goal is supposed to achieve. So for instance, given a goal, a goal in a particular blockchain, for instance, you want to hash a particular function, or when you get a data, you want to hash it, or you want to store it on blockchain. So this function to hash a given data, do you want it to be transparent, the hash? Do you want the data to be transparent? Do you want it to be based, the hashing to be based on standard rule? This is when we talk about the trusted part of it. The integrable, do you want this function to be integrable across all the main components? Interoperability, do you want this particular function to be accessible to other interfaces, traditional interfaces for executing the apps? Secure, do you want this function that you execute, do you want it to be accessible to only a particular kind of people, so that only them have access control, or do you want to maintain access control for this particular function? Highly automated, like I mentioned before, it's executed by a software agent. That means it's very fast. You don't have to be a human to execute this. Modifiable, do you want this smart contract function to be modifiable later? Because the smart contract functions we are referring to are actual business processes. So we know that businesses change or their value change. So once we build a smart contract and publish on blockchain, it's not modifiable. So when we say modifiable, we are referring to how you want to manage this kind of the state change, how you want to manage the entire the app in terms of versioning, and when you have a new version. The usability, the name is quite simplistic, it's quite basic. You understand what usability is all about. Then the scalability, how scalable do you want to have this function to be executed? Portability talks about where do you want to have this function accessible, on phones, on computers, or other device. Performance means that you want to execute this function in high number over a given short period of time. So this is basically the whole concept about the whole idea about the DAOM. And the last that I'm about missing is the sequence object. So we map the agents and we map the sum component into the main sequence object. The activity for the sequence objects represents the user interactions in the DApp. So the on-chain events are the activity that results in the state change in the blockchain. So that we use this meta model as a way to present this whole picture of the blockchain. So to recap what I just said, the goals are refined into sub-goals. The goals functions represent state that you want to achieve in given the app. The on-chain label is used to attach to the goal that results in the state change in the blockchain. And quality goal defines how a goal is achieved based on software. Agents are users or software that interact or execute a goal. The heuristic mapping, here we have the heuristic mapping. So we map the goal into components. So here we map the first level goal into the main component and second level goal into the subcomponent. So we'll show this during the demonstration for the running case, and it will be more clear when we get there. So this is what we call the heuristic mapping of the goals into main components and subcomponents. And the tokenized component represents interfaces that capture the value exchange between different components. The sequence objects represent the use case of the DApp, and then on-chain events shows the state that result in the token in the change in the blockchain. Okay, so we apply this our meta model, our DOM in many use cases, but we want to present a sample interesting use case that we worked on last year, in 2019. So this use case is about attestation and verification of digital documents and online. So the idea is this: when you access a given service, a web service that involves a lot of money on backend transaction, they might want to know your cost. They may want to know your customer attestation. So this know your customer attestation, the traditional way it is done is that you send your document to a particular e-service, then they give these their identifiers, they identify you and say you are who you are, and then you get the service. When you go to the next service, you repeat the same thing. So the chances that you are wasting more time doing the same process of what you've done with another company before, and then there's also a chance that your attestation or verification might come out negative because every time the result is not always the same. So you want to be the idea is that you want to be verified once, and the result of the verification stored on blockchain, so that you can easily capture these results and reuse it next time that you want to do verification or attestation in another e-services. So this solves the problem of delays and then the failure of positive verification, even though you have been positively verified before. Okay, so here we have from the meta model that we just showed and the elements that make up the DAOM, we present the goal, the requirement diagram of the DAOM. So this screen you're seeing is the implementation of the two supports. Here are the elements we showed before: the goal, on-chain label, quality goal, emotional goal, the agents, the user story, the refinements, and the association. So generally, you see the goal and the goal elements and the users, and then below you see the user stories. Yeah. So the user stories are attached to the goals that are on-chain goals. We use this label to show the on-chain goals. So these are the user story. So let's start with the main functions. So the main function for this particular DApp here, the value proposition of the DApp is this: attest and authorize digital assets. So like we said before, they want to be able to say that information you presented, that you are who you are. So once we verify that you are who you are, we store it on blockchain, and then you can reuse it in any e-services anywhere in the world, because the blockchain is supposed to be accessible by everyone. Okay, so if you're able to attest your, the whole idea is to be able to attest and authorize your digital assets. So the main value propositions are the first level goals. So these are the ones that start at the top, this, and this. So the first one is the manage key. So the first time you come in the app, you want to be able to create your keys. That is your own identification, the public and the private key. So the next step after creating your public and private key, you want to be assigned the correct role you want to play in the app. So like we mentioned before about the use case, you have the web services, you have the identifiers, and you have the users of the web services. So in this case, after a user creates their own key, they are assigned to the role they are going to play in the app. That is the onboard user. So when you onboard the users, and then they have access to their wallet. And the next function, interesting function, is to be able to create transactions. The whole idea behind the blockchain is that you want to create transparent transactions, you want to create visible transactions, you want to create tamper-proof transactions. So the transactions we are talking about here are, in this case, are captured in this main value proposition: store asset information and attest asset. So if you look here, when a user wants to use a given e-services, then they provide their ID. So this ID is then used to create a request, a verification request transaction. So if the e-services create this verification request transaction, they publish it on blockchain. And then these identifiers, the people that actually identify people and attest that you are who you are. So they attest this your ID. So this your ID, in this case, we are referring to assets. So when they attest your asset, they verify you and store the verification information on blockchain. And then these transactions that are created here have to be validated to be correct. Also, the verification request transaction has to be validated before they are published. So the next interesting transaction here, the next interesting function here is also the block creation. So after you create this type of transactions, for instance, you want to request a verification, or you have been verified and your information is to be stored on blockchain. So this function helps us to be able to map this block creation correctly. So in the managed block, we should be able to elect block producers, and we should also be able to produce blocks. So the elect block producers captures the rule for selecting the next block producer. Generally, the app uses this decentralized proof of stake consensus method. So this consensus method is used to select the next block producer. And here we capture the main stakeholders that participate in the app. So we have three interesting stakeholders: the identifiers. Okay, let's start with the acceptors. I said are the e-services that you want to access. The donors are the people that want to access a given e-service, and the identifier are the people that conduct the manual verification and store your verification status on blockchain. So these are the main categories of users we have in this particular app. Okay, so acceptors, they create attestation requests. The attestation request is I have a user that have to be verified. Can you do this? This is a request, you put it on blockchain. So the next one is the identifier. They create this verification transaction that says you have been verified positively or you have been verified negatively, and then they store it on blockchain. Then the donor are the owner of the ID that wants to be verified. So these are the three main classes of users. So like I mentioned here, we also have another group that we call active users or active participants. The acceptors and the identifier are the active participants in this blockchain. And what the active participants do is that they involve in the block creation. So when this software agent here elect the block producers, they are actually electing between the identifiers and the acceptors, who are the active participants that create the block in the blockchain. So the general idea behind the decentralized proof of stake is that you want to associate some group of people to be able to produce the next block. Not everyone wants to be participating in the process of block creation. Some people just want to be onlookers or less participants. So in this case, the identifiers and the acceptors are the active participants. So the consensus agent is the software agent that is responsible for electing the block producer. So now let's look at the quality goal. Interesting thing here is this: when we look at this particular elect block producer, which is a function that is executed by this consensus agent, you see we have it to be highly automated. So highly automated means that it's going to be executed by a software agent. We also have this block production. We have it to be transparent. So all the blocks stored in the blockchain is transparent. So this transparency doesn't mean for outsiders. Transparency in this case is referring to the acceptors, identifiers, and donors. So these are the participants in the network. So these are the people that it is transparent to. So transparent means that all the block produced here is going to be visible to everyone. So let's also pick another interesting function here. So here, when you create your key, we make it scalable. That means that we want that if 1,000 users start using this app today, that this system should be reliable enough to create this number of user keys without failing. That's why we made it scalable. So even if 1,000 users or 1 million users join the platform, we should be able to generate unique identification for them. So the technology of generating the unique identification is not what we cover here, but the whole concept of how you do this systematically without missing any particular function is what we want to cover. And also the usability here means that you want the users to easily create their keys. It doesn't have to be so complex that you have to log in somewhere and start downloading some software. You want it to be so easy that once you come up in the app, you should be able to create your own identification. So that is general idea behind these quality goals and the quality goals attached to these functions. Okay, let's also look at another interesting quality goal. Which other one? So performance. So when you publish, we have this managed transaction. So these two types of transaction that we create in this DApp, verification request transaction and attestation transaction. They are gathered together, they are all gathered and then published from this by this function. So in this function, you create this transaction rule. So the transaction rule has to be, let's see, it has to be highly automated because it's created by a software agent. And then it's also scalable and it's also secure. It's transparent. Publishing transaction in the blockchain is performant. So when we evaluated this blockchain in the actual white paper of this company that we work on this project with, so we actually saw that the performance of this blockchain in terms of the number of transactions published, we measured it in terms of time, and it's very higher than Bitcoin and Ethereum, of course, because they use proof of work, but this is a proof of stake, so the number is quite high. So this blockchain, this publishing of function here, we can for sure say that is highly performant. And then when we come to the user story, so the user story, like we said, are the functions that result in the state change in the blockchain. So when you publish transaction in the blockchain, there is a state change in the blockchain. So here we have a transaction is executed by the acceptors or by the identifier. So any transaction published here can be executed, a transaction from the acceptor, a transaction from the identifier, which is this verification request transaction and attestation transaction. Okay, we go back again. The user story again, this particular user story is this: an acceptor publishes a transaction containing identity verification request for a given donor. So a given donor brings the ID and say, I want to get verified. So these guys, accept, publishes this transaction containing this verification request. Then for the onboarding participants, so to transfer token, a user can transfer token. So when you join in the platform, to be able to execute this transaction, you need a token for sure. So you can request a participant to transfer a token to you. So the rest of the user story are quite covered in detail in our white paper, which is not really important in defining the main concepts of the blockchain. So like we mentioned before, we do heuristic mapping to generate the main components and the architecture of the blockchain. So in the heuristic mapping, the first level goals, which we have about, let's go back again. So let's count it. We have 1, 2, 3, 4, 5, 6, and 7. So these 7 main components is what we use in the these 7 value propositions is what we use in deriving the main components or architecture of the system. Okay, so one of the main advantages of doing this way is that you can easily map these interfaces to the users who are going to execute functions in them, because we already captured these users in the goal aspect. So it's easy to see these interfaces. Who are you designing it for? This interface, this component, this is the interface. So these interfaces, who are you designing it for? So this interesting interface, this interface component attestation request, and then attestation processing component. These are 2 interesting interfaces. So this interface is linked to the acceptor. Okay, this interface is linked to the acceptor, and this interface is linked to the identifier. That means if you are building this DApp, only the acceptor should have access to this interface, and only the identifier should have access to this interface. So let's go through it one by from the beginning. So from the beginning, you create a public key, and then you create an account. A public key is generated for you, and then you get onboarded. Then you get onboarded to be assigned to your particular role. So you see all the stakeholders, all the participants in the network, all the participants in the network are able to generate their key, and then the data that is exchanged between these component, and this component is this public key, because with this public key you can assign a role and say, I want to be an active participant, I want to be a identifier, I want to be an acceptor in the system. Then you get onboarded to your role. Then if you get onboarded, then this communication channel is the component that the identifier and the acceptor uses to exchange this digital asset. This asset we call digital asset is simply ID document, whether it's a driving license, a educational certificate. You use it, you exchange it. This guy hashes it and stores in this component, and then produces a transaction that is published through the transaction manager. So all the transactions generated in the attestation processing components and the attestation requested components are gathered together in the transaction manager and then used in creating the blocks. So if you are voted in to create the next block, you gather the transactions from here and then publish it. So in this case, the transaction manager or the participant should be able to have access to the transaction manager because they want to see which transaction is published. And then the consensus agent have access to the consensus manager where the rule for electing block producers are. Okay, like we mentioned, the agents and the data exchange are some of the important elements that we capture in this static architecture, because it's more easy to develop interfaces for people that you know. So you know this group of users and this is what their interface is going to be like. You know this other group of users, this is the interface they are going to be like. And the data, we also capture the interesting data. So some of the data exchange in this architecture is the public key. The public key is generated in the key manager. We have the donor ID document. The donor ID document is generated here in the create communication channel where these guys used to generate the data and store on their digital asset. So this data is then exchanged to the identifiers. Then the next is the token balance. Everybody has access to their own wallet. So because to publish an on-chain transaction, you have to be charged some money. So everybody have access to this wallet manager where you have your token balance. Then the last but not the least is the attestation result. So the attestation result is produced here by the identifier. So after receiving the verification request produced here, they verify you and publish the results through the transaction manager, and then it's stored on the blockchain. Okay, that is it for the static architecture. I know there will be a lot of questions, then we'll come back to answer specific questions because it seems a little complex. Then the use cases is what we use to describe the use case diagram. The sequence diagram is what we use to describe the main operations that is carried out in the DApp. So for this particular DApp, some of the interesting operations that we capture here is the payment. So if people transfer tokens between each other, the payment transaction, this payment operation is quite basic. That's why we didn't capture it in the picture. But what is happening here is just a token exchange between participants. The verification request and transaction, that is the first one. So let's look at here. This is the sequence object that I mentioned before. The sequence object is acceptor, donor, transaction manager, and block manager. Okay, so in this case, the acceptor gets ID data from the donor. Yeah, so the donor sends this data to he makes a request and then gets the data. So this data is hashed and then matched with the key of the identifier and then published on the blockchain. So you see, whatever that is happening here, getting data, hashing it, getting public keys and returning a complete transaction and publishing it on the blockchain until you get to where you have the state change in the blockchain, which is the publishing the transaction, is where we have on-chain event. So this on-chain event captures that there is a exchange of value in this point. So because you are publishing this transaction, you are going to lose some amount of token. So when you publish this transaction and then it gets stored on the block manager on the blockchain, and then the block details is returned to you. The block number, the transactions contained in the other transactions contained in the block, and your specific transaction is returned to you because you created this request. So the next is the attestation transaction. So the identifiers are the people that do the actual attestation that say who is who in the blockchain. So the identifiers look at this transaction that is published on this blockchain. They gather this transaction. They get request transaction, their hash and the ID of the identifier of the acceptor that publishes it. They gather this transaction and then make a check on the blockchain. Is this ID hash, does it exist before? Do we have a verification result already for it? So if it doesn't exist before and there is no verification that exists for it, then they go ahead to request an ID data of the donor. They hash this ID data. They do manual check on this ID data and then say this ID data actually is correct or is positive attestation. So the process of doing this, of publishing this positive or negative attestation here, results in the state change in the blockchain. So that's why we have this number here, which shows this on-chain event number 2. So then we publish in the block manager, then the block details is returned to the identifier. So the block details contains this transaction, the attestation status transaction, and then the other transaction that is published with it, and the transaction number. Okay, so we have last two interesting transactions that we also want to talk about. These two transactions, they are called commitment and secret transaction. They don't result in any state change in the blockchain. So this is generally about the block generation and election of who will create the next block in the system. So what goes on here, in the first time when you instantiate the blockchain, a Genesis block is generated, and this Genesis block serves as input for selecting the next block producer. So we have in this particular blockchain, they have what they call commitment key and secret key. So this commitment key and secret key are some set of random numbers that the active participants in the network publish and say, I am ready to publish, I'm ready to create the next block. So this generate commitment number and secret key. The consensus manager gathers these two transactions from the active participants and uses the time difference, some kind of time difference they call the epoch, and then do some calculation to generate randomness. So this input, the transaction 3 and 4, are input for randomness generation. So when you generate randomness, then you can be able to randomly select the next identifier or the next acceptor to create the next block. So if you are choosing as the next block, so if you are choosing as the next block leader, so what you have to do is when you are choosing is that you go to transaction pool, which is transaction manager, gather the transactions that make up a block, and then use it to create a block, and then the block detail is returned to you. Okay, so this is the whole general idea about we just showed in brief and what we have been working for the past 2 or 3 years in just a quick summary. I think some of the things might need additional explanation, additional clarification. So the main idea is this. So we have a model-driven way to systematically design a DApp, and we also have a way to systematically say that who is going to perform a what function. We also have a systematic way to say these are the set of data that is generated in this DApp, who have access to it. And we also have a way to say these are the interfaces that exist in this DApp and who have access to it. And we also finally have a way to say that these are the on-chain events that exist in this DApp and who and what does it and how much does it cost. So I want to also get back to this. So with these two transactions, for instance, this verification request transaction and then the attestation transaction, you can build a business model around your DApp and say, this is the cost structure, this is how it's going to be. If you execute this transaction, I make this amount of money. If you execute this transaction, I make. So you can build your business model around this because this is the value where you are getting your value from, because these are the ones that cost money to execute in the blockchain. Okay, so the next steps for the DOM is more use cases. We already have maybe up to 10, I think up to 10 use cases, but the more we have use cases, the more we also get more, the more our framework gets used in solving real issues. And then the next step is also automation, the code generation aspect, because what we currently have is we model the system, but the developers have to build the code by looking at the functions and then mapping into the code and say, does the code satisfy the function? So the next step logically for us is to say, this is the function, this is a common function, is the app. When you click this particular button, it generates the code. Because we already have this interesting thing here. We already have this what is it called? We already have these two support. So, but what is missing in our two support is the code generation, where you have to click a button and smart contract codes are generated for you. Okay, so that is it from me.